far beyond the gentle warmth of the sun, beyond the quiet orbit of Mars, beyond the swirling stones of the asteroid belt, lies a frontier most humans never think about, the outer reaches of our solar system. A region so empty, so silent, so untouched by sunlight that even the planets feel like distant memories. And from that cosmic darkness, from a place colder than imagination itself, a ghost drifted inward. A fragment of a world that was never ours. A traveler older than our species. A messenger from a star we may never discover. Scientists named it 3I Atlas, the third confirmed interstellar object ever found. For months, astronomers watched it with every tool we had: optical telescopes, radio antennas, infrared sensors, long-exposure cameras scanning the night sky. But then something happened. Something no human instrument had ever recorded in the entire history of science. JAXA's XRISM X-ray observatory turned toward this interstellar wanderer. Not with visible light, not with infrared, not with the ordinary colors of astronomy, but with X-rays, the most energetic, most revealing, most unforgiving light in the universe. And at that moment, reality changed. For the first time ever, a visitor from another star system glowed in X-ray light. A halo, a shroud, a whisper of impossible photons emerging from a cosmic stranger. Tonight, we pull back that glow layer by layer. We decode it. We follow its message across time and space. And we try to understand what secrets an object born around another sun has carried into our cosmic neighborhood. This is the story of 3I Atlas and the first X-ray portrait humanity has ever taken of an interstellar traveler. Before we begin, tell me in the comments, where are you watching from? A rooftop? A mountain? A bright city drowning in light? Or somewhere dark enough to see the universe breathe? Tonight, we stand on the edge of discovery. Let's begin. Most telescopes are trapped in the prison of human sight. They see only what our eyes can see, ordinary light reflected by familiar worlds. But XRISM is different. It observes the universe through soft X-rays, wavelengths so energetic that black holes flare like beacons, exploding stars burn like furnaces, and neutron stars scream with radiation. Comets, however, do not glow in X-rays. Not normally. Not at this intensity. Not from this far. So when XRISM aimed its Extend instrument toward the faint smudge of 3I Atlas, scientists expected almost nothing. A few scattered photons. Background noise. Maybe a faint hint of charge exchange. But XRISM waited. It collected photon after photon, silently, patiently, like a night watchman listening for the smallest whisper. Hours passed, days passed, data accumulated, and then something moved in the darkness. A glow, soft, widening, growing like a ghostly shell around the comet's coma. A halo of X-ray light, faint but unmistakable. This was charge exchange, solar wind ions slamming into neutral gases released by the comet. But this glow was stronger, sharper, more sustained, more structured. Something about 3I Atlas was not like the comets born under our sun. And that difference would lead scientists into the heart of a cosmic mystery. Humanity has only confirmed 3 interstellar visitors: Oumuamua, a strange, elongated object with bizarre acceleration and no visible gas tail; 2, I Borisov, a more traditional comet but unusually rich in carbon monoxide; 3, I Atlas, the quiet traveler now drifting past our sun. But only this one, 3I Atlas, allowed us to see it in X-rays. This is not just a scientific first, it is a cosmic first. For billions of years, interstellar fragments have crossed our solar system unnoticed. For tens of thousands of years, Humans have watched comets streak across the night sky. For decades, astronomers have photographed black holes, galaxies, and exploding stars. But never, not once until now, has an object from another star system revealed its chemistry in X-ray wavelengths. This isn't just a glow, it's a message, a fingerprint, a piece of cosmic DNA. XRISM did not just see the object, it decoded it. And what it found inside those photons changed everything we thought we knew about interstellar visitors. When XRISM broke the comet's glow into a spectrum, like splitting white light into a rainbow, 3 bright lines appeared: carbon, nitrogen, oxygen. These are the building blocks of comets. But more importantly, these are the building blocks of life. They tell us what the comet is made of. But they also tell us something deeper. 3I Atlas was not born near our sun. Its chemical ratios do not match the comets native to our solar system. Its oxygen peak is slightly shifted. Its carbon line is unexpectedly sharp. Its nitrogen signal is unusually stable. These differences are subtle but unmistakable. They reveal that Atlas formed in a different temperature environment, in a different molecular cloud, under a different stellar chemistry, around a star that lived a different life than our sun. In other words, its atoms are a message from a star system humanity will never see. A message written billions of years ago. Scientists expected Atlas to behave like a normal comet, but XRISM revealed 3 stunning differences. Even after accounting for XRISM's sensitivity, Atlas's X-ray lines are unusually sharp. This suggests less dust contamination, more volatile ice, a colder birthplace, a slow, quiet formation far from its parent star. This comet may have formed in the deep outskirts of another solar system, farther out than even Pluto or the Oort cloud. Most comets flicker in response to solar wind changes, but Atlas, it stayed steady. This indicates a smoother nucleus, very few fractures, no explosive jets shooting gas into space. This is rare. Most comets behave like cracked icebergs, unpredictable, chaotic. Atlas acts like something preserved, untouched, ancient. Its carbon to nitrogen to oxygen ratios do not match solar system comets. Not alien, not artificial, just foreign. Forged in a stellar nursery our telescopes have never mapped. Its glow is not just light, it's a memory of its birthplace. This discovery reshapes our understanding of the Milky Way. Interstellar objects are samples from other worlds, but we almost never get close enough to study them. X-ray spectroscopy changes that. For the first time, scientists can study the chemistry of distant star systems, the composition of alien ice, the life cycle of stars across the galaxy, the diversity of planetary nurseries. This glow is not just a scientific curiosity. It is a window into the kinds of worlds that exist beyond our sun, a window we have never opened before. In control rooms across Japan, teams monitored XRISM's instruments. It took years of planning, endless engineering, tight orbital schedules, solar avoidance windows, weeks of exposure stacking, careful photon filtering, and then the halo appeared, a circle of X-ray light wrapped around a visitor from another star system. For the first time in history, humanity saw an interstellar object in X-rays. That moment belongs not just to scientists, but to all of us. Because discoveries like this remind us what it means to be human, to question, to search, to find beauty in the impossible, to understand the universe we live in. From this one glow, science gained 4 profound truths. Oumuamua, Borisov, and Atlas behave nothing alike. It's simply one example among billions. We can now analyze visitors from other stars using X-ray light, because now we know what to look for. XRISM opened a door in the universe, and we're not closing it. Close your eyes for a moment. Imagine a star system billions of years ago, a sun older, colder, or hotter than ours. Planets forming, dust swirling, comets freezing in the distant dark. One of those comets, a fragile, icy shard, is knocked loose. It drifts into interstellar space, cold beyond imagination, lonely beyond words, traveling for millions of years. It passes dead stars, silent nebula, clouds of frozen gas, the ruins of civilizations that may have risen and fallen before humanity ever existed. And then, it enters our system. For a brief moment, a cosmic heartbeat, it glows in X-rays, and we see it. A connection across space, across time, across the histories of two suns that will never meet. This is not just astronomy. It is poetry written in starlight. Now, 3I Atlas is fading. Soon it will leave our solar system forever, returning to the endless dark between the stars. But its glow remains in our data. Its message remains in our detectors. Its truth remains in our understanding. The universe is bigger, stranger, more diverse, and more beautiful than we ever imagined. If this discovery sent a shiver down your spine, hit like. It helps this channel reach more curious minds. And answer these questions. Until next time, stay curious, stay brave, and keep looking up. The universe is speaking. And now, for the first time ever, we can hear it. In X-rays.